Okay guys, welcome to your first flip lesson of the year. Remember, like I told you in class, to pause and take notes, just like you would in class. You can always watch the video through one time and then go back and try to get some important points out of it and write those down. And then any examples that I have, make sure you write those in your notes and be prepared because there might be a quiz question or a suggestion for a ticket in the door before we're done. Okay, so the first thing that I want to do is go over a graph that should be somewhat familiar. One where you have a point P, and in order to find the slope of the tangent line, which here is pink, we're going to look at slopes of secant lines. So your first Q sub 1, let's call it, would be right here. So this is a slope of a line which passes through 2 points, which makes it a secant line, where the slope of the secant line doesn't really come that close, right, to estimating the slope of the tangent line. But the closer the point Q moves to the point P, and I'm throwing some other ones in here, then the slope of the secant lines get closer and closer and closer and closer to being the slope of the tangent line. Now, if I try then to label some points, let's say that I want to call this point A, or if I call the curve F, then my point P is A, F of A. And let's look at the point Q as some other X value. And this is the one that's moving, right? It's moving, it's moving, it's getting closer and closer. But let's just look at this particular point Q. Any one of these I could label as X, F of X. Then you would know how to get the slope of the secant line most definitely, right? You know that the slope of the secant line is the y minus the y over the x minus the x. So this is a little clearer on the next page. So if you want to write it down from a clearer formula, here we go. So again, this is point A, this is the x value A, this is the x value x. So here is the difference in the two y values, and here's the difference in the two x values, right? So that's exactly what we just looked at on the last page, and that brings us to a formula. So here's the formula. The tangent line to the curve has this slope. So the curve is y equals f of x, the point is a f of a, and at a f of a you have a tangent line through P, and again, here's the slope, provided that this limit exists. Now what we're going to do with this picture is just look at how the same exact scenario plays out if we label the points differently. So now this is remaining A, okay, so the point where we want to find the tangent line slope, that's still going to be at A f of A. But the other one, instead of saying that this is a point X and that this point is X f of X, we're going to instead say, okay, I don't want to necessarily name that point. I just want to say that the distance between those points is h, and that's indicated up in that triangle. But from A to this point over here is a distance of h. So that means that this value would be a plus h. So when you label the point, it would be a plus h. For your x coordinate, and your y coordinate would be f of a plus h. Alright, so then what happens? I'm going to sort of, not ignore, but I'm just going to use the slope formula and not necessarily look at what that says or what that says. So if I want to write the slope of the secant line, just like I did on the first page, I'm going to say, okay, my slope is y minus y and this will be neater on the next page, and then over x minus x. And you could probably see what happens, right? Let me switch some colors here. So up at the top, nothing happens. F of a plus h minus f of a, that stays. But on the bottom, I could say a minus a goes away. So then my formula becomes this. So here, And now we're adding something else in it that, darn it, now that I think about it, I'm not sure if I added it in before or if I spoke about it, but we need a limit, right? So on this one, as the distance between the points gets smaller and smaller and smaller, or the distance between the points gets closer to 0, then this formula for the slope of the secant line actually is going to be the slope of the tangent line. So again, we have our y minus y over x minus x, came down to h, and as that distance gets smaller and smaller, that gives us the slope of the secant line. Now one more reminder, since again, I know when we went over the other slide, I didn't say anything about the limit. So the slope of the tangent line with a different formula, and again, remembering that you could label the picture differently, this is one formula for the slope of the tangent line, and another formula for the slope of the tangent line is a limit, and I'll fill in what the limit has, what is approaching what in a second, but we have f of x minus f of a over over x minus a. And if you remember on that particular picture, it was as x was getting closer and closer to a, correct? That's how the secant lines became closer and closer to being the tangent lines. So as x approaches a. So here's an example that we're going to try. But first you should probably pause this and try to get this answer yourself. Also go grab your calculator, because with most of these, it's not that you can't do it without a calculator, but when you're subtracting different numbers that you see here, well, not up at the top, but when you're subtracting different numbers, it's up to you, but you can have a calculator for these if you want. So go grab it, try this yourself, and then hit play and see if you got the right answers. Okay, I'm going to start by doing A and Roman numeral 1. So if I want an average rate of growth, then I'm going to use two different points and actually get the slope of a secant line. So an average rate of change is the slope of a secant line. So if I want to get it from 1996 to 1998, I'm going to be using those 2 points. Alright, so for this one, I'm going to take, for 1998 and 1996, those are my x values, right? Change in x goes on the bottom, change in y goes on the top. Alright, so now I have my calculator, and when I subtracted, I got 871. On the bottom, I did that subtracting in my head. Okay, so I got over 2, and my final, once I divide that, is I get 435.5. Alright, so what is this? This is an average rate of growth. Now, we always want to get our units right. So the number of n locations of a popular coffee house chain is given. So this is how many coffee houses. Say, I don't know, for instance, perhaps Starbucks, and here's the year. So all we want, as far as a label then, is going to be coffee houses, and I'm trying to write an S there, per, or you could do a slash, but I was out of room, year. Okay, so that is your answer for Roman numeral 1. I want you guys for tomorrow to do 2 and 3, and I might just have a little poll ready for you guys to take when you come in. Okay, in each case include the unit, so make sure you do that. After that, I guess I can't finish anything else with you, because once you get your, basically your slopes of secant lines from 96 to 98, then from 96 to 97, then from 95 to 96, notice you're honing in on 1996, right? So you're going to use those 3 slopes to come up with some kind of an instantaneous rate of growth, or, you know, guess to an exact slope of a tangent line, really, for 1996. Here it's actually telling you take the average, if you're going to average together 2 of your average rates of change, and then again give units. And then you're going to estimate the rate of growth in 96 by just measuring the slope of a tangent. And for this one, you would actually just be graphing. And you don't have to use a calculator or a regression equation. It's up to you. You can use a regression equation or just carefully label your axes. Much more evenly spaced than I just threw that there. Plot your 5 points and actually measure out a slope and count rise over run to, again, estimate your slope. Okay, see you in class tomorrow or Tuesday, whenever that is for you.